Google serves 10 completions before you finish a word, across 8 billion searches a day, all in under 100 milliseconds. This is the system behind it. You type how to ma. At 3 characters in, over 1 billion stored queries share that prefix. A naive scan of every string in the database against your prefix would finish long after you stopped caring. The fix is pre-sorting results by prefix once, offline, so each keystroke hits a pre-computed answer list. You accept results up to 24 hours stale in exchange for sub-millisecond reads. The data structure is a trie, pronounced trie, a tree where each edge is one letter. How to ma traces 8 edges down from the root to a single node, 1 hop per character. Each node stores the top 10 completions for that prefix, ranked and frozen at build time. When you reach the node for how to may, you get the full answer list in a single memory read. No traversal needed. The API sends your prefix to the trie service, which walks 8 edges from the root, 1 per letter, landing on the node for how to ma. That node returns a frozen list of the top 10 completions from RAM in under a millisecond. No sort, no filter, a memory read, and a return. How to make pasta outranks how to make an armadillo cage because millions more people typed it and clicked a result. Without ranking, autocomplete is alphabetical order, and that tells you nothing. Each node holds a sorted array of the 10 highest scoring completions. The score is a 7-day running query count, aged down slightly each day so a surging search surfaces within the week. At build time, you merge child nodes bottom up, and each parent keeps only the 10 highest scoring completions across all its children. The array never grows past 10 entries, so storage stays flat no matter how deep the trie goes. Every completed search fires an event into a log stream. The API writes it asynchronously after it's already returned the response, so logging never adds a millisecond to the read path. Nightly, an aggregation job reads the full log, counts each query string, and computes the top 10 completions for every prefix, meaning every node in the trie. The rebuild trie is serialized and written to a snapshot store. Each trie service instance pulls the new snapshot on a rolling schedule, no traffic interruption, no downtime. The trie service hot swaps the old tree for the new one in memory. From the outside, the change is invisible, and stale results last at most 24 hours, which works for nearly every query pattern. The top 1,000 prefixes, things like the, how, and wa, account for roughly 20% of all traffic. Cache those in Redis with a 60-second expiry, and most requests never reach the trie at all. Every request checks the cache first. A hit comes back in 3 to 5 milliseconds, about 10 times faster than a trie walk, and costs almost no CPU. For how to ma, if anyone searched that prefix in the last 60 seconds, you return their cache result. You pay for the computation once and spread it across every concurrent user on that prefix. On the client, debounce fires a request only after 150 milliseconds of silence. A fast typist generates 15 keystrokes in 3 seconds, but debounce cuts that to 3 network calls, so the trie service never sees the intermediate characters. One trie server holds the full index in RAM and handles around 10,000 requests per second. At Google scale, you shard by prefix range, putting A through M on one cluster and N through Z on another, each replicated 3 times. The trie is read-heavy and updated at most once a day, so there's no write contention. Add read replicas freely. Replication is your horizontal scaling lever, not complex partitioning logic. The API layer routes each request to the correct shard based on the first letter of the prefix. Users hit a single endpoint and never see the routing. Rebuilding every 5 minutes instead of daily keeps trending queries fresh but multiplies the compute cost by 288. Most teams run daily builds and add a real-time layer only for breaking news and trending queries, where staleness actually costs engagement. Pre-compute offline, serve from RAM, cache the top prefixes, debounce on the client. In a system handling 1 billion queries a day, answers how to ma with how to make pasta before your finger lifts off the keyboard.